Thanks everyone for joining tonight. This is Nicole Matson with the Climate Change Coalition. We're here with Steve Vavrus tonight for his presentation, How Will Wisconsin and Door County Be Affected by the Climate Crisis? What does the latest research tell us? So we're really excited about that tonight. Thanks, Steve, for joining us. Just want to remind everybody to please make sure your microphone is off, and you'll find a little icon that's here. And then just, make sure it says it's off with that slash through it. And just keep that off throughout the presentation, just so we don't have any distractions while Steve's talking. This presentation will be followed by a Q&A session. So if you'd like to ask a question, please use the chat box. And if it's too long of a question or you'd rather ask in person, you can just type your name into the chat box. And then when we get to that Q&A session, we will ask you to unmute at that time. Just a little bit about the Climate Change Coalition. We are a volunteer-driven nonprofit focused on public education on the science of climate change and hoping to inspire action to combat the climate crisis. If you'd like to learn more, our website is climatechangedoorcounty.com, or you can find us on Facebook and Instagram. We also have a YouTube channel, Climate Change Coalition of Door County, and that's where all of our virtual presentations have been going. So if you'd like to see past presentations, or this presentation tonight is being recorded. So if you'd like to rewatch it or share it with your friends, it'll be there. You will get an email when that recording is ready. And if you've registered through Eventbrite, you'll just see that email already in your inbox because you're on that Eventbrite list. This is a presentation from our season of action this year. We did the Door County Big Plant this spring. This is our last installment of the Wednesday speaker series. And then this summer, we'll have a bunch of educational field trips and hikes as our fundraisers. And thank you to all of our sponsors. Just an update on the Door County Big Plant. If you haven't heard, we worked with 37 organizations and individuals, and we planted over 19,000 trees and plants in Door County. So it's been a really great success, and thank you everybody for your help and getting those trees planted. A little bit about the summer field trip fundraisers. This is to support our work and our free programming that we do throughout the year. We have one coming up this Saturday at the Wasita Farm Tour. There's also one in August. There's a local flora and fauna at the Ridges with Katie Krause, and then we have an Ephraim Swamp Tour with Lee Freilich, one in July and one in September. And you can find more information on our website about that, or you can contact me, Nicole at lnrp.org, to sign up or to find out more information. And then I just want to give a warm welcome to Steve again. Thanks so much for joining us. And I'm going to flip this over to Roy Thilley, our steering committee co-chair, and he will introduce Steve.
Thanks, Nicole. Can you hear me? I should check.
Yes, I can hear you.
Great. Thanks very much. And I'd like to welcome everybody who's here tonight. We're grateful for your attendance, and we're very pleased that over 100 people have signed up tonight, which is just great. This is the third speaker for this season of action, which we're doing online in lieu of the in-person forum that we did for 7 or 8 years up until last year. And we're certainly hoping to get back in person next year. I'm sure we will. We're also very pleased to have Steve Vavrus join us tonight. Steve is was a speaker at our 2017 forum, where he talked about extreme weather. It's kind of easy to persuade Steve to come back because he has a lovely cottage in Ellison Bay and knows how special Door County is. He is a senior research scientist at the UW-Madison Nelson Institute for Climate Research. So he is in the heart of the climate change issue. He works with computer models and also with observational data to understand what's happening around the world with our climate, with a particular focus on extreme weather. Importantly, Steve is a co-director of Wiki, the Wisconsin Initiative on Climate Change Impacts, which came together between the Nelson Institute and the DNR back in probably around 2008 or 9 when the first task force was formed. And Steve will explain it better than I can, but what Wiki does is to assess current and predict future impacts on Wisconsin of our changing climate to drive understanding about what's happening, mitigation,
I'm glad it's not being recorded.
lessen climate change, and adaptation, which, excuse me, hit the mute button, to adaptation so that we are able to accommodate the changes that are going to happen no matter what. And there's lots of interest, obviously, by the signups tonight. When we had Catherine Heo speak a few weeks ago, she emphasized the importance of talking about what's happening in people's lives today on climate change, that people relate more to what's in their backyard than to polar bears. But as Steve will tell, Steve is an expert on Arctic weather and what's happening in the Arctic, and it's important. And we're lucky to be here in Door County, but we will be in fact affected, as Steve will explain, but affected not only by what's happening here, but by what's happening around the world. And will by drought and by conflict and other problems that climate change is driving. So with that, I'm going to turn it over to Steve and let him go forward. Thanks very much.
Thank you very much, Roy. And I will start sharing my screen here and bring up my presentation for us. All right. So are you able to see that okay?
Yes,
Okay, how's that?
that's good.
Good. Okay, I'm getting into laser pointer as if I were really there. And so, you know, the virtual world, here we are. I'm happy to be with you virtually tonight. And it's great that everybody's able to tune in from the comfort of their own homes. And the talk tonight, it's gonna be kind of a telescope talk. We're gonna go from the very big scale, global, down to the national scale, and then the state scale, and then finally the small zoom in on the Door County scale. And first, I want to give you a little bit of background about myself, since you don't really know me, except for that very brief introduction. So I've always had a fascination with weather. Growing up in central Indiana, lots of tornadoes and blizzards and whatnot. And when I was a student at Purdue, I was a meteorology major, so I knew that that's what I wanted to do for my career. But when I graduated, I had developed a real interest in environmental issues in college, and I was trying to find a way to merge those two interests. And climate change seemed like the logical way to do it. And so I enrolled as a graduate student at UW-Madison all the way back in 1990, and I have not left. I have graduated, fortunately, but I have not left the university in all that time. And that speaks to how great a university it is and how great a state Wisconsin is to live in. And as Roy mentioned, I am lucky enough to be firmly entrenched in Door County as well. My wife and I bought this cabin 7 years ago in Ellison Bay. And in fact, I am presenting right here from this very room. So I'll wave to you, and that is exactly where I am right at this very moment. And Roy also introduced Wiki, the Wisconsin Initiative on Climate Change Impacts. And maybe by virtue of seniority in the state, I was named a co-director a couple of years ago, along with Pam Porter of the DNR and Dan Weimott, also at UW-Madison. And Wiki is a partnership between the DNR and the Nelson Institute for Environmental Studies, where I work. And it's been around for almost 15 years now. So we've got quite a track record. And just to give you a little bit of background about us, it's a hard organization to describe because we're not a traditional top-down type of organization you may be accustomed to. We are really more of a catalyst. We sit at the interface between science, climate science, and adaptation to those climate changes. And our mission is very practical, to generate and share information that fosters solutions to climate change in Wisconsin. So we're very much pragmatic, trying to find solutions to accepting the reality of climate change. Now, what do we do about it? And I do want to promote that we have a new assessment report coming out this fall, probably in September. This is the first one in 10 years, and so it's high time we updated the science and also what we know more about adaptation and the changes in climate in Wisconsin and beyond. The scope of Wiki is pretty broad thematically. We pretty much group into these 4 categories of air, water, land, and people. Within those categories, we have various working groups with expertise in Wiki members. And some of these you would sort of expect you'd cover in climate change, right? Agriculture and human health and water resources. We also have some new working groups covering the Great Lakes, could be of interest to you in this audience, tourism and infrastructure, which has now become our biggest. So we're sort of opportunistic wherever the expertise lies, that's what we target. But I think we have pretty good coverage on the things that we would expect to be important for impacts of climate change in Wisconsin. So taking a step back, why is Wiki even necessary? Well, back in 2007 and even more so in 2021, weather and climate is dominating the news. This is a collage I put together of headlines just in the past year. Just to remind ourselves, last year around this time, there was a really bad heat wave that was cooking Siberia, hit 100 degrees north of the Arctic Circle. The other extreme, this winter, we had, of course, the big snowstorm and ice storm that knocked power out in Texas. Last summer, we had a record-breaking hurricane season. We ran out of letters of the alphabet to name the hurricanes. There were so many. And at the same time, we had the other extreme of Western wildfires and killing some people and causing terrible property damage. And then closer to home, the derecho, the windstorm in Iowa last year, it was the most costly thunderstorm disaster in US history. I think it spared Dorr, but it certainly clipped southern Wisconsin. And this is just a smattering of a few that I pulled off in the past year. So this is really something when we have this many major weather events and climate news in such a short amount of time. And that last year was not a complete anomaly either, because we've been seeing an increase in these weather disasters, extreme weather events over the last several decades. This graph shows the number of billion-dollar weather disasters in the US over the last 4 decades. And the bars represent the number of such events in a given year. So 1980 had 3 of them. And it's color-coded according to the type of extreme weather event, whether it was a hard freeze, a flood, a winter storm, drought, or what have you. What I really want you to look at is just eyeball the fact that there's an obvious upward trend toward the present. Especially the last decade, we've seen an unusually large number of these extreme weather events, expensive weather events in the US. And last year was by far a record. We had $22 billion weather disasters, which easily broke the previous record of 16. So not only was 2020 an awful year for public health and the economy, but it also was really harmful or damaging in terms of weather. So Mother Nature was playing a role as well. It's not always obvious what the relationship is between extreme weather events and climate change, but we do know that obviously the climate has been changing. We're at the point now where we're setting global temperature records practically every year. So this is an example, another headline from the New York Times from 2016. They kept having to change their headline because they went from 2014 as a record, 2015 a record, and then 2016 a new record. And it really hasn't cooled off much since then. 2017 was the 3rd warmest year on record, 2018 the 4th warmest, 2019 the 2nd warmest, and depending on what data set you look at, last year was either the warmest or the 2nd warmest year on record. So clearly not just due to chance, we are now expecting near record or record-breaking heat all the time. That's the global average picture, but it's much more enlightening to look at the spatial patterns across the globe in these warming trends. And we can go back a lot further than the last decade. We have a good global temperature network, thermometer network going back almost 150 years now. And what's shown here is an animation from NASA. And the blue colors represent below normal, below the long-term normal. And the warm colors, orange and red, represent above normal. And these are displayed in 5-year chunks, so averaged over 5 years to get rid of some of the year-to-year variability. And I'm going to loop through this, and you'll be able to see the transformation of climate over these 140 some years, and starting mostly with blue colors representing the early years that are cool, and then transforming to the warm colors lately. So here you see the world is awash in blue, smatterings of yellow in the late 1800s. Now we're at about 1920. You see a little bit of a warming here in the 1930s, and then a cool down mid-century, still 1950s, 1960s cool. But notice now in the late 1970s, that's when you start to see the bright colors emerge. And they just get brighter and brighter and brighter until the animation ends. The last years are ending in 2018. And wow, this is a whole different ball game, right, compared to where we started. So lots of oranges, yellows, and reds. The Arctic is the area of the world that's warmed the most because of the loss of the chilling ice and snowpack. But also notice that land has warmed more than the ocean. And that's especially true in Eurasia, but it's also true in North and South America, all the continents, right? Africa, Australia. And you're hard pressed to find too many regions that are blue anymore, and almost none on land. So this gives us a sense of how the climate's evolved, at least in terms of temperature over these 140 years, and how really almost nobody's escaping the warmth anymore. It's no secret as to why the Earth has been warming. We've been pumping huge amounts of heat-trapping gases into the atmosphere, especially since the Industrial Revolution, and even before with the advent of agriculture. And you've seen probably lots of graphs that show the rise in carbon dioxide, methane being another important greenhouse gas. But this is an interesting figure I took from the Washington Post from a few months ago. This is a different way of displaying it. So this isn't going back 150 years. This is going back about 800,000 years. From air bubbles trapped in ice cores from Antarctica, we can figure out what the carbon dioxide concentration of the atmosphere was at the time the snow fell and then later turned to ice. So we have very accurate records of what the atmospheric CO2 concentration was going back, way back in time, 800,000 years. And this graph shows the changes per millennium from 800,000 years ago toward the advent of the Industrial Revolution. And the reason I'm showing it is that it shows that naturally there are these slight changes in carbon dioxide concentration just because of processes internal to the atmosphere. Naturally, humans aren't really playing a big role here. And they're very modest. I mean, you can go through an entire millennium and have virtually no change. At most, we see about a 20 part per million increase over a millennium. The present day atmospheric concentration is about 420 to put it in context. But to really put it in context, I'm going to show here the last millennium. We've blown things out of the water here. So compared to the natural record of about 20 increase in a millennium, we're more than 6 times that in the past millennium. And the lion's share of that has happened just in the last century, mostly because of industrialization. So even setting aside climate change, humans have fundamentally altered the composition of the atmosphere in a very, very short amount of time, geologically speaking, shown here. So that's the big global picture. And that's the broad scale part of the telescope talk. But now we want to zoom in, get down to more of a Wisconsin and Door County scale. And in the next few slides, I'm going to show some iconic images of Wisconsin just to remind ourselves of how strongly a role the climate plays in shaping, shaping our state, whether it be the landscape of Wisconsin, the economy, or our culture. So for example, the rich fertile soils that cover much of the state thanks to the glaciers. This has made Wisconsin a bountiful state, made a great agricultural land, whether it's for farming, livestock, or what have you. course, the frozen tundra of Lambeau Field, not far from here. Even though Wisconsin's warming, we're still relatively cold compared to the rest of the country, giving the Packers a home field advantage, of course. And we have plentiful cranberry bogs in the central and northern parts of the state. Again, thanks to climate, a lot of the favorable peatlands, peat marsh lands that make them well suited for growing cranberries. The kettles, the kettle lakes down in southeastern Wisconsin and the marshes from the retreating ice sheet about 10,000 years ago created this scene from Horicon Marsh. And a huge quick climate change that happened as one of the big lobes of the ice sheet melted back very quickly, creating huge meltwaters and creating the Wisconsin dells. And it's hard to get a more iconic image of a Wisconsin landscape than that. In the Southwest, the glaciers didn't reach the driftless area. And as a result, we have a very different kind of landscape than we do in much of the rest of Wisconsin. In that part of the state, we have rolling hills, lots of valleys, lots of rivers, very few lakes. So again, the climate played a role by not glaciating that area. And then finally, very close to home, the presence of the moderating climate due to the Great Lakes, particularly Lake Michigan for Door County, has created an optimal climatic environment for growing certain types of fruit, such as cherries and apples. And so Door County owes a lot of its cherry image to the fact that the glaciers, when they retreated, left behind the Great Lakes. And so that too has affected our economy and also our culture in this area. So in all of those ways, Wisconsin and other states too, of course, are affected so strongly by the climate, the past and the present. So any sort of change in climate is going to have lots of repercussions, including cultural. And so I'm going to now show some of the data that demonstrates what kind of climate changes we've experienced locally in Wisconsin. And the two operative words here that you're going to be hearing a lot from me tonight are warmer and wetter. So if you want to just summarize it in 3 words, that describes our climate change of late, and it describes the climate changes we're expecting in the future. So what I'm showing here are temperatures across the state and precipitation amounts averaged across the state, going back all the way to the 1890s. That's when we have really good records for Wisconsin. And I'm averaging these by decade to really help remove some of the year-to-year fluctuations and capture the longer-term trends. So you can see Wisconsin's temperature record by decade. And just like the other bar graph, I just want you to first kind of eyeball the fact that the warming trend is obvious. It's not completely even. There have been decades like the Dust Bowl in the 1930s that were quite warm, but even that wasn't nearly as warm as where we are today. The last 2 decades have been Wisconsin's warmest on record. Similarly, for precipitation, you see a distinct upward trend, although it's a little bit different pattern in that, of course, you see the really dry 1930s here, but what really grabs your attention is the fact that the last decade was so very wet. We set by far a new record for wettest decade, and it wasn't even close. We broke the previous record by about 10%. And for good measure, 2019, the final year of the decade, was the wettest year on record, going back to 1895. So if it seems like it's been really wet lately, it has, and it's been record-breaking wet. And as an example of that, in March of that year, 2019, the combination of heavy rains and floodwater created scenes like this. This is from Darlington, but all the way from Nebraska, Wisconsin, Minnesota, most of the upper Midwest was having major flooding problems thanks to all the rain and snowmelt. But 2019 wasn't a total fluke either. It was really kind of the exclamation point on an extremely wet decade, not only for the total rainfall and snowfall, but for the extremes as well. This is showing a map of the number of 100-year daily rainfalls during the past decade. And that means that these are daily rainfall amounts that you would expect to occur only once per century. But in fact, based on data that my colleague Dan Weimont put together, at least 20 such events affected Wisconsin during the 2010s. And it wasn't like it was all in one part of the state either. You see, almost every area was affected except maybe right in the middle. Door County was not spared. We had some really heavy events too. And so these are the sorts of things that can create real havoc, not just the totals, but the extremes. And probably not far removed from most people's memories, if you were here in Dora at that time, the most famous flood of recent years is probably the 2014 flood that affected much of the county, really, really heavy amounts, up to 7 inches in Ephraim, nearly a half a foot in Fish Creek and Egg Harbor, causing extensive infrastructure damage and so forth. So even though this part of the state is typically receives less rainfall and less extremes than other parts of Wisconsin, Door County has been hit as well. I don't know if it makes us feel better or worse, but we're not in this alone. The whole country has been seeing a big increase in extreme precipitation events over the past decades. This is a figure that shows the breakdown by sector, and it starts in the late 1950s and goes close to present. It shows the increase in the very wettest days, the top 1% of all rainfalls, whatever magnitude that is in a different part of the country. And the West has been going up more modestly, but it too shows a positive trend. And the biggest increases in the nationwide are in the upper Midwest, and even more so in the Northeast. So this is all part of a longer term trend. We expect in a warmer climate, more moisture can be held in the atmosphere. And so when conditions are right for a heavy rainfall, even more rainfall can be wrung out. So this is not a surprise. One of the problems with heavy rainfall, aside from the obvious infrastructure damage and annoyance of a wet basement, is that it can actually be problematic for human health. Waterborne diseases are much more prevalent after we get a heavy rainfall. Probably the most famous example was about 30 years ago in Milwaukee, this cryptosporidium outbreak leading to a boil water order. It was the largest waterborne disease outbreak in the country's history. Over 400,000 people became ill from it, and it was preceded by record rainfall. So it was one extreme example of how heavy rains can actually directly affect human health. So that's the wetter part of the warmer and wetter trend, but what about the warmer part? So one practical impact that a warming climate has is on our lakes or recreation. This is a picture of Lake Mendota in Madison, which is considered the most studied lake in the world, they say, because of researchers from UW right on campus, right on the shoreline. And the reason I'm showing it is because Lake Mendota has this amazing long record of ice cover going back to the early 1850s. So even predating temperature measurements, we have a record, an indirect measure of climate for Madison, which is representative of southern Wisconsin and the longer term trends typical of the whole state. This graph is showing the total duration of ice cover starting in 1852. And you see lots of up and downs representing just, year to year weather variations. And then the smooth line in red, you see a little bit more clearly the downward trend. But I think despite the variability from year to year, you can pick up the fact that, for instance, the 5 winters that had the most ice cover were all in the 1880s or earlier. And the 5 winters with the least amount of ice cover were in the 1980s or later. So very clear record of a warming climate right here in Wisconsin. If we move ahead a bit in time, we can get more precise data, temperature data and precipitation data broken down in different parts of the state. What I'm showing here are changes in the annual mean temperature and annual precipitation for different parts of the state, starting in the mid-20th century. So this is about a 70-year-long record. And we've broken it down here. This is a map that we put together in Wiki and our center. And it's showing Wisconsin's 9 climate divisions from north to south, east to west. And the color coding here indicates the yellow regions indicate a 2 degree Fahrenheit warming trend over those 70 years, and the gold a little bit higher, about 3 degrees Fahrenheit. And the asterisks represent that these are statistically significant warming trends. So they're not likely to be due to chance. They really are representing a warming climate. For precipitation, we also see that the whole state's been changing in the same direction, but here we see more spatial variations. For example, the north has only seen about a 5% increase. The rest of the state is significant. The north is not. The south central, southwest, and west central Wisconsin have seen the biggest increases in precipitation of about 20%. That's really a lot over a 70-year period. But here, Dorr is somewhere in the middle of those two. That gives us a sense of what we've experienced, but we can't change the past. So we can learn from it. We've had a lot of good stress tests to deal with as preparation for the future climate changes, but we really want to know what's the climate going to be doing in the future. And for that, our best crystal balls are global climate models, computer climate models like the kind I work with and my colleagues work with. And I'm going to be showing some results here for Wisconsin from those climate models from a set of about 24. And we've taken these coarse scale global climate models and done something called downscaling. So the global models don't account very well for things like the Great Lakes and the Mississippi River Valley, but we can do that using known relationships between large scale patterns and surface weather conditions. And we can tailor these global climate predictions or model predictions and come up with estimates that are suited for the scale of a state like Wisconsin. What I'm showing here are the projected temperature changes put together by Wiki for the late part of this century, the last 2 decades of this century, compared to the most recent decades, so the climate we've gotten used to. And it's for what's considered a middle of the road greenhouse gas emission scenario. We don't know exactly how our emissions will change in the future, but this is sort of a middle of the road estimate of what might happen. Notice the colors here. So not surprisingly, the entire state is expected to warm, but notice the magnitude. Before, it was a 2 to 3 degree warming over the last 70 years. And what the models are suggesting is more like a 6 to 7 degree Fahrenheit warming over the next 70 years. So really much bigger. And here in Door County, they're estimating about a 6 degree Fahrenheit warmer climate. And to put that into perspective, that would mean that Sturgeon Bay in the future, by the end of this century, would have the temperature climate, at least, of that of present day Chicago. So you just zoom right down Lake Michigan and boom, there we are with a very noticeably different climate than what we've been accustomed to of late. We can do the same kind of exercise for precipitation. Again, the model suggests that the whole state will change in a uniform direction, but interestingly, the magnitude is fairly modest. So the models are suggesting about a 5% increase in precipitation in southern and central Wisconsin, about 10% in the north, similar in Door County. And yet that's actually smaller than many changes most of the state has experienced over the past 70 years. So if we're fortunate, some of the heavy precipitation increases we've seen of late will actually not be so much greater in the future, at least in terms of these totals. We can break down these annual patterns by season because sometimes you get very different expectations from one season to another. What I'm showing here are winter, spring, summer, and fall, and same time periods as before. But notice a couple of things. One, as you'd expect, all seasons show warming for all parts of the state, but there's really not that big of a difference from one season to the next. If you compare the colors from this annual average, very similar to summer, similar to fall and spring, we do see somewhat greater warming expected in winter as we lose much of the snowpack. But other than that, it's not too different from one season to the next, nor is it too different from one part of the state to the next. So in terms of our seasonal and spatial temperature patterns, it looks fairly similar regionally and by season. For precipitation, it's a little different story. So this was the annual map that I showed before for expected precipitation changes. And here we see by season, winter, spring, summer, fall. Winter is the season we're expecting to see the biggest percentage increase in precipitation in the future, followed by spring, fall somewhat less, but summer is a real wild card. So I'm highlighting it with a big question mark because this is the average of about 24 different climate model projections for summer rainfall. About half think that we're going to get wetter and about half think we're going to get drier. When you average them all together, you get a very washed out pattern that suggests not much change, But I would say that the real story here is that we just don't know. People like me need to figure out what's going on with these models and which ones are trustworthy and which ones are not. So the wetter winters and springs, I think we can be more confident of. Summer, much less certainty. Now, it's not just the averages that matter, of course, it's the extremes. I'm going to show here some examples of projections of extremes. In this first example, extreme heat. This is for late century, and it's now assuming a high-end carbon emission scenario. The metric I'm using is 100-degree days. I think we cheeseheads can all agree 100 degrees is a hot day around here. And mercifully, we rarely get to 100 degrees. Definitely not in Door County, but even in the southern part of the state. But that's expected to change in the future. You see a lot more bright colors by the end of the century. Still not super common, but as much as maybe a week or two a year, 100-degree conditions in the far south. But the reason I'm really showing this is I want to show you the buffering effect of Lake Michigan, relevant for this crowd. So you see along the lakeshore, you can pick any part of the Lake Michigan shoreline and see that there's very few 100-degree days expected in the future compared to inland. So you just pick any spot, compare it to the west, and definitely Door is best off compared to anywhere else in the state because of the buffering effects of Lake Michigan and to a similar smaller degree for Lake Superior. You can do the same sort of comparison for extreme precipitation in the state and same time period as before. In the past, using a metric of 2 inches or more rainfall in a given day. And the parts of the state that are most afflicted by that are the Northwest, the West Central, and the southern part of Wisconsin. Fortunately, here in the Northeast, we're largely spared. We've not seen a large number of really heavy rainfalls because we're typically too far away from the moisture that's transported up the Mississippi River Valley. That same spatial pattern is expected to continue in the future. The places that are most susceptible to flooding rainfalls are expected to remain so in the future, but now everything goes upward. So even in Northeast Wisconsin, less of these events than in other parts of the state, but still a lot more than we've seen in the past. So that's something that climate models have been very confident about in the past, and that a warmer climate, because more moisture can be held in the atmosphere, we expect more extreme rainfalls to occur. And then the final example is for extreme cold. These are nights below 0 Fahrenheit. And the typical pattern is the north woods. The farther north you go, pretty much, the more of these really cold nights you get. Fewer in the south, and even fewer in the east and southeast. Again, the cooling, or the moderating effect, I should say, of Lake Michigan, it shows up really clearly. You can pick any point along the shoreline and see that the number of really, really cold nights is less than it is inland. And that pattern will probably continue in the future, but according to this projection, we may see no more. We may see a disappearance of these extremely bitter nights by the end of the century. So we'll see if that plays out. It would certainly help human comfort and our heating bills, but it would certainly also have a lot of ecological implications. And finally, I would be remiss with this group if I didn't bring up the topic of water levels in the Great Lakes, particularly Lake Michigan. This is a highly researched topic, and it's certainly been in the news a lot. We've seen literally a record low value in 2013, only to get to the other extreme of near record highs in 2020. If you were around here last summer, it was amazing how high the lake levels were. And this was just over a very short period, not even a decade. The levels have come down very recently, but you can see that they're still very high. Now, for the future, we'd like to have some sense of at least the direction of change, whether they'll get higher or lower, but unfortunately, the models really don't agree. The bottom line is there's lots of uncertainty in our projections of Great Lakes water levels, including Lake Michigan. This is a set of predictions from climate models for Lake Michigan water levels for the future. This is the baseline 2020, mid-century, and late century. And the boxes represent where the middle 50% of all the models project the lake levels will change, or how they will change. And then the extreme, the outlier models are shown here with the whiskers and the crosses. And so for the 2050 future and the 2080 future, they suggest, modestly lower if you take the red line, which is the average of all the models. But I think you'd agree that the real story is the huge range of projections. Some models think we'll get 3 feet higher, a meter higher, and others suggest we might get 2 or nearly 3 meters lower. And so that doesn't lead us to a lot of confidence in our planning for how Great Lakes water levels will change. What they do suggest, though, is that we'll see more of these short-term fluctuations like we've seen during the last decade. So taking a step back, we've talked about how the climate has changed. We've talked about how we think the climate will change. And now the big question is, what can we do about it? And for that, I'm going to shift my tone a bit. I know that a lot of the material I've presented can be very despairing when you think about our future, but there are some signs that we can really tackle this and really make some strides and improve our future. One reason for optimism is that there's been some really good science communication messages that have come out lately by people like Professor Ed Maibach at George Mason University. If you think about like advertising a marketing campaign, he's tried to do this with climate change to really boil down the complexities and all the information we face on this topic. And he sums it up in 10 words that you can use with your friends and neighbors and colleagues and family members. He says, it's real, it's us, meaning people. Experts agree, it's bad, but it's solvable. And so those are some 10 words that we can build on, and it's the it's solvable part I want to talk about next. So one reason why there's some guarded optimism here is that we've seen some shifts in public opinion in recent years about this topic of climate change. The Yale Climate Change Communication Program puts together surveys every year to gauge Americans' interest level and concern about climate change, and they created what they call the 6 Americas, that being people who are alarmed about climate change, those who are concerned, cautious, disengaged, doubtful, and downright dismissive. And what's encouraging is that even over the last 5 years or so, the number of people who are alarmed has more than doubled. So you really can't tackle this problem on the big scale unless people care about it. And I think that's a good sign. And also the number who were dismissive has shrunk by about half since the polling began in 2015. So I think these are both encouraging trends as we're winning over public opinion. There's also a lot of co-benefits if we tackle climate change. My colleague Jonathan Patz at UW-Madison, who's also an MD, makes this point frequently. So for example, if we clean up the atmosphere by reducing emissions from smokestacks, we'll not only reduce carbon emissions and help climate, but we'll also reduce premature deaths from air pollution and asthma and the like. So a win-win. Also, shifts in diet, shifting to more of a plant-based diet doesn't mean people need to give up meat, but shifting more toward a plant-based diet has been shown to cut emissions, and it's healthier for us. And then finally, transportation. If we can take some of these shorter trips by car and go instead by bicycle or by foot, if possible, that will help us increase our physical activity and also cut back on emissions. Another example of what we're already doing in terms of adapting to a climate change is these heat wave action plans. These are guidelines that have been put together by numerous municipalities across the country, and they've been saving lives. They're really common sense approaches. So when heat waves are forecasted, one tip is to simply publicize these heat waves better. We're never caught off guard by a heat wave anymore. The Weather Service forecasts are accurate enough that we know they're coming. They need to be publicized, similar to what we do with winter storms. Communities, especially urban areas, can set up public cooling centers, whether they be public libraries during the day or overnight facilities as well. And we need to reach out to the most vulnerable populations who are affected most by heat waves. We know who they are. They're elderly, socially isolated, and disabled people. Those are the ones who typically die during heat waves, and sometimes even just knocking on your neighbor's door, your elderly neighbor's door, to check on them during a heat wave is enough to save a life. These heat wave plans are still being evaluated, but there's a lot of positive signs from various big cities across the country. And the most dramatic example I can find is for Chicago. They had that notorious heat wave in 1995 that killed over 700 people, largely because the city just didn't take these things seriously. They didn't know how deadly they were. In 2012, there was a comparable heat wave and fewer than 20 people died, largely because Chicago had plans implemented to deal with a public health emergency created by a severe heat wave. So as the climate, just a final point, as the climate warms more and more, we expect more of these heat waves, and steps like heat wave action plans will become more important. More action at the national level. President Biden has taken climate change a lot more seriously than his predecessor, implementing some aggressive plans, at least. He can't execute them himself, but he has put the country on a goal toward net zero carbon emissions by mid-century, re-entered the Paris Climate Agreement, established 2 new cabinet level climate advisors that had never been done before, and an emphasis on environmental justice, the recognition that climate changes, like other environmental problems, do not affect all of us equally. Some people are much more susceptible than others, and we need to address that reality. And it's climate change is a key component of his new infrastructure plan, which is still being debated in Congress. At the statewide level, there's also been action at the executive branch. In this case, Governor Evers, a couple of years ago, created the Governor's Task Force on Climate Change through an executive order. And that group has finished and sent its 50 or so recommendations to the governor to consider. These involve largely energy reduction, but also adaptation actions. And that created the Office of Sustainability and Clean Energy. And that office is tasked with making Wisconsin, electricity consumed in Wisconsin, 100% carbon free by 2050, keeping very much in line with the national goal now. And also in line with the national goal, making sure Wisconsin is fulfilling the carbon reduction goals of the Paris Climate Accord. My time is about up, at least for the presentation part. I'm happy to take questions. I'm going to springboard a bit for the summary slide off of Professor Maibach's climate change summary and dissolve this into my climate change summary for the state as I've presented tonight. As I've said, ad nauseum, warmer and wetter. Those are the trends in Wisconsin in the past and those that we're expecting in the future. We're also expecting in general more weather extremes, particularly heavy rainfall and extreme heat, probably fewer extreme cold waves, but those will be made up for by more extremes in other types. Soggier winters and springs can be expected both by more rainfall in those seasons and potentially snowfall, but also snow melt. Door County is certainly not going to be spared from climate change, but in some ways will be partially tempered, especially from the extreme heat by virtue of being right next to Lake Michigan. And then finally, ending with a question, double question mark, Great Lakes water levels. We'd all like to know how those will change, but right now it's mostly a state of uncertainty. So that is a topic of climate change research that will be ongoing. I will end there and turn things over to Roy or to Nicole, whoever's going to be taking over the presentation now.
Thanks very much, Steve.
Able to.
Can you hear me?
Let's see. I can. I'm trying to stop sharing. So now you ought to be able to see me and I can see all of you again.
Great, thanks. If you have trouble hearing me, let me know because I did have a message that our internet connection is unstable. I think that's what it usually is. So if people in the audience have questions, please feel free to type them into the chat or to just say you have a question you'd like to ask and we can unmute you to do that. To start things rolling, it looks in general that Door County is in a good position because of Lake Michigan and the cooling impact of the Great Lakes, compared to the desert Southwest or other regions of the world that you showed. Has anybody been doing research, I assume they have, on likely population shifts as a result of climate?
It's a great question, Roy. And the reason I say that is because we have gotten a surprising number of suggestions from our Wiki working group members that we need to address that very topic. That's something that I don't think we even touched in our 2011 assessment report, but it's gotten on people's radars now. And so I agree. I think we do need to study this. I think it's a very complicated question, but Wisconsin should be in better shape than many parts of the country, Door County within the state also. So I think this is something that needs a lot more research, and it needs to be people who are not physical scientists, demographers, geographers, economists, all sorts of people sitting at the table trying to figure out this one. Because in terms of planning and zoning and whatnot, we really need to have answers to that question.
Great. I assume, the question for us is, do we need to raise the drawbridges? We're experiencing development upsurge right now, I think because of the pandemic, actually, people moving out of cities. And one can see in the maps that you show how many 100-degree days can you withstand in Phoenix after a while.
Right, and even in other parts of Wisconsin, I mean, Door County is also already such a great place to escape to in the summer, partly escape the heat. And if more of the state is having heat waves, it stands to reason that a place like Door would be even more attractive.
Okay, I've got a couple questions. One from Terry Kita, which is if land is fallow in Wisconsin, not in production, what would you say is the best vegetation in terms of reducing carbon dioxide? Maybe a little bit out of your area of expertise, but
yeah, it is a bit out of my area, even though I grew up in the cornfields of central Indiana. I wasn't part of an agricultural family. So I don't know the answer. I know who to contact to help answer that question. But I do know that there's been a big push lately toward more sustainable agricultural practices and healthier agricultural practices, things like no-till farming and cover crops that help draw down carbon in the atmosphere. So I don't know specifically the answer to your question in terms of the best vegetation, one being better than the other. But there is evidence that there's a whole range of more sustainable agricultural policies that are beneficial in terms of climate change, but also can be beneficial economically for farmers.
Yeah. My 2 cents on that one is that it's a hard question to answer. Obviously, reforestation would probably have the biggest impact, but of course that takes the land out of production permanently. But there is significant reforestation on marginal lands that can occur in Wisconsin that would be significant, would be very beneficial.
Yeah, and there's also a push towards something called silvopasture, which is more popular, I think, in Europe, which is a combination of forest and pasture land. We typically think in this country of kind of monocultures, either something's a forest or it's a field of corn or soybeans. But having a combination of grazing land and trees and so on, there's some synergistic benefits of doing that, and that's also part of this whole sustainable agricultural thrust.
Thanks. I see that Dick Smythe has a question, and I will ask to unmute. Dick?
Yes, thanks, Roy. Steve, first, let me just congratulate you on the quality of your visuals. They were very clear, very, very well done. So thanks very much.
Thank you.
So the question I have is, do you have any data on the increasing populations of noxious critters, i.e. mosquitoes, ticks, black flies, and so forth and so forth?
The one that's been making the news the most is ticks and Lyme disease. And boy, we've certainly seen it around Wisconsin, haven't we? That one, I had always assumed that was pretty much direct effect of warming climate. I'm told by entomologists it's not that simple, but that climate warming plays a role. So I think to some degree the increase in the prevalence of Lyme disease and ticks in general probably is a sign of a warming climate, but it's more complicated than that. I don't know about some of the other critters you mentioned in terms of flies and so on. Certain types of mosquitoes probably who aren't killed off by the cold are probably thriving. But, you know, even in our warming climate, just this past winter, we had that cold stretch in the middle of February when it was sustained cold for a really long time. I mean, something like 2 weeks straight. And then 2 years ago, we had near record or record breaking cold for a short amount of time, that so-called polar vortex. And so oddly enough, even in a warming climate, we can still get these intense outbursts of cold air, which we've seen a few times now in the past decade, that can be beneficial if we want to rid ourselves of some of those pests for more southerly climates we'd rather not have in Wisconsin.
I'm walking through the questions. There's several comments on the population concern, which is not surprising. One question is, could you talk a little bit about permaculture restoration? I'm wondering if that's in your wheelhouse at all with your study of the Arctic.
Oh, so permafrost?
Permaculture, I'm not sure.
Permaculture. Well, restoration agriculture, maybe? Is that what, it's what I was talking about earlier. I'm not sure the term permaculture though.
Okay, well,
but restorative agriculture is what I've heard used also.
I'll see if I can find it, find the person to ask the question directly, because one of the questions that we have is about Wiki and whether we're getting a leak or whether Wiki's information is generally available. And I think that, I think you do have a website and a lot of information, is that right?
Something happened, yeah.
Oh, is Roy frozen?
Oh, I'm sorry. Nicole, can you take over?
I am here, so we'll just.
Okay, we might be getting him back.
No, I'm here. Can you hear me?
Yep, I can hear you, Nicole. Are you back?
Can you hear me?
Yep.
Yes, but you're kind of broken up.
Yeah, I'm back. So Rennie and Dave, I think, is the one who asked the question. I just asked you guys to unmute if you can hear me. And ask that question.
Just to follow up on that question about permaculture, that is a concept that predates what now is very often referred to as either eco agriculture or restorative agriculture, and it is very much oriented towards maximizing the diversity and mimicking the ecosystems of nature, but making them nudging them to be productive into things that we need and want, rather than this producing really what are really temporary deserts, the huge fields that are tilled most of the year and not producing, not sequestering any carbon. If you could speak about that a little bit. I don't know if you know, Gabe Brown speaks quite a bit about that.
Yeah, and for everyone, there's a great documentary that's out. It's called Kiss the Ground, and it's all about restorative agriculture, I think is the term they used. And now you're saying permaculture is an older term, so maybe we're reinventing the wheel now again. But it's as you say, diversity, no-till, cover crops, various techniques. Sort of a handful of 5 principles that are fairly, very organic and have benefits in terms of bottom line and also for the climate. So I can't speak too much beyond that because I'm not an expert on agriculture, but I think it's an encouraging sort of news that shows how soil health and agriculture can be an important player in the solutions for climate change.
Steve, I'm back. I hope you can hear me now.
Have you back, Roy? You're loud and clear.
And maybe in conclusion, I just ask you, I know what you do is modeling, and that sounds easy, but these models are huge and very complex, I suspect, from having not having done models, but having reviewed the results of them in the power planning energy area. Could you speak a little bit to the complexity of the models and how you deal with that complexity through sensitivities, through averaging of different models? Because one thing we all know is we can't predict the future, but models provide us with indicative results, I think, which is important, with directional results.
Right. So these computer climate models are really complex, and nobody, even climate modelers, people who develop them, people like me who use them, nobody is an expert on every aspect. So these are, many, many lines of computer code. They're trying to represent the behavior of the atmosphere, ocean, land cover, ice, and so on, and to some degree now even human behavior. So they're really complicated, and we do need reality checks to make sure we understand which ones are behaving realistically and which ones we should throw out. And so, as Roy said, we do tests. Scientists look at how well they simulate, say, the present day climate, how well they simulate recent climate trends, variability, extreme events, how well they handle those. And from that, we get a sense of which models are more trustworthy than others. And we use that information in part to gauge how much weight to put on one model over another in projections of future climate change. It's not perfect. It's a combination of art and science. That are issued, and he's got to make sense of them. And sometimes they agree that one candidate will win, and sometimes they don't agree. And then just like climate models, so like for summer rainfall in Wisconsin, if half the models say we're going to get wetter and half say drier, what does a climate scientist like me tell the public? What's going to happen? And so there's the development of climate models, the usage, and then the interpretation. And so they can all keep someone like me busy and employed for 30 years or so, and hopefully another 10 or 20 years down the road.
Well, thank you very much, Steve. It's a great presentation, and thanks to everybody for coming. And in conclusion, I'd say the Climate Change Coalition can always use volunteers, donations if you wish, but what's most important is your interest in the issue and talking to your friends and neighbors. And one of the questions we had was, what is the most important thing that one can do? And I think that's to live consciously in terms of your impact on the planet, one, and two is political action, because ultimately major change will come through the political process. So thanks, everybody, and enjoy the weather up here. It's been beautiful this week. Take care.
Thank you.
Thank you.